All right. Our next speaker, Sandra Paul.
Thank you. I'm very happy and honored to be here today talking a little bit about time I spent with Wendell and some things that I learned from him. I was his graduate student. I graduated from UC Davis in 2012, and now I'm associate professor at San Jose State University. Okay, so you'll notice that models is missing from the title of my talk. The title of my talk is The Impact of Student-Centered Assessment Techniques on Student Success in Class. And there's a reason for this, that I'm sort of not talking about models, just in this has been talked a little bit about today so far. If you look back to the name of the course, the class course that Wendell created and instituted, it's called Collaborative Learning Through Active Sense-Making in Physics. And models is actually missing from this title as well. And the story behind this is that we threw out so many different acronyms at him when we were trying to figure out what we're going to call this. We can't call it Physics 7 anymore. That's the name of the course. We got to have a name for this curriculum. And I think one of the reasons is that he didn't want the acronym to be CLAM, but collaborative. But the other one was that when you asked him, Wendell, what do you really care about? What's important to feature about this course? And he said that the collaborative learning and the sense making were the most important part. And so the models were really just a way to get that done. And so really, CLASP is more than modeling. And so I'm going to spend time today talking about the other things about this class that made it so radical, as Chuck used that word, and I like it. I think it really captures the fact that this class is very different, and I'm learning how radical it is as I'm implementing it now at San Jose State, and I have a lot more respect for him, and I had a lot of respect for him before, but even now it's even more so, because it's a challenge to do a reform on this scale. So Wendell really thought that learning is about conversation and making sense of things. This is just one of his core beliefs, and the models were whatever you need to do this well. And in this context of this class, his models are whatever you need to do this in the classroom. But there's this whole other conversation that's happening outside the classroom. And this conversation is between the instructor and student, and it's through assessment. And so I think it's really useful to think of assessment as a conversation that's happening, because it really can be used both to inform learning on both ends, from the instructor and the student. And I think it's important to remember that while assessment is not the only way you talk to students, in some ways we don't want it to be the most important way we talk to our students, but it often is this loudest way that we're communicating how well the students are being successful in this course. And so Wendell believed that assessment and feedback process should be meaningful and student-centered. And for this reason, he sort of thought about this in two different ways that I'm going to talk about today. You have this performance feedback and evaluation, so how well did you accomplish something? And also this improvement feedback. How can you do better next time? What can you do to be successful further on? And so that's how I've decided to outline my talk here. I'm going to talk a little bit about, I'm talking two methods that are different. We talked about all the ways that class is different in the classroom, but I'm going to talk about these two ways that it's sort of different, that it's outside. It's sort of the management of the class. So one is improvement feedback, to use this method called grading by response category. And also with respect to performance feedback and evaluation, he thought it was very important to have a meaningful grade scale. So something meaningful both to instructor and student, and sort of standardized. And then finally, I'm going to talk about the impact of the CLASP assessment practices, and I'm really glad Chuck spoke before me and mentioned that it's so hard to sort of piecemeal out what was successful and what isn't, all the different changes that were made in this CLASP course. But I'm going to just show sort of what the impact was the quantitative impact in this particular course. So all of those methods combined. Okay. One thing I will say before I move on is that Wendell was really, really good at not just creating a course, but institutionalizing it. And the reason that he did it was exactly for the reason that Chuck said. He would make it difficult to go back. So he would actually make it easier to do these things. So it's not that he used these specific types of these methods for assessment, he made them part of the course. He made them so that it would actually be more difficult not to use them. So this improvement feedback method called grading by response category, we have a physics teacher article on it if you want to look up how to more on it. But basically the big idea behind grading by response category is that you're separating out student solutions by their biggest error. Okay, so one error, maybe two. Okay, but the biggest thing, the thing that you want them to pay attention to next time, that's how you're doing it. And you're not creating these categories ahead of time. So what you're doing here is, and don't worry, I'm not going to make you read the you can't read it. I'll tell you about it. But I wanted to sort of let you visualize what's sort of happening when you actually when you do this in practice. So you'll give a problem to the students, and then once the students turn in their solutions, you start looking them over and you separate them into categories. Okay, and these categories, as I said, are based on the students' biggest errors. So here's an example. I have this example here of a train. The train has 3 different cars, and all the cars have different masses, and the train is moving at a constant speed. And the students are asked, do all the cars of the train have the same kinetic energy? And so when you're going through and you're grading these things, you might see a score. I might see a solution that you think is perfect. Okay, but instead of writing like 100 or 10 out of 10, you give this perfect solution a code of Q. Okay, that's just a letter, a code of Q. And you write that on the top of their page. And then you're going to define what it means to have a perfect solution. So I've just written some things down here. It's perfect. The cars have the different kinetic energies, even though they have the same speed. Kinetic energies are different because the masses are different, and here's the formula for kinetic energy. So this might be what you have decided as an instructor is a perfect answer. Maybe you have more things that go in there. Maybe you have fewer. It doesn't matter. You get to define this. And then from there, you are going to separate all the other ones into other categories of biggest error. So for example, this particular student mixed up weight and mass. They had a very similar solution to Q, but instead they said weight instead of mass. And so instead of having a Q, you give them a symbol of R. I'm just making up letters here. Okay, it doesn't matter what the letters mean at this point. And then here's just another one. This student said that the KE is the same because the cars are traveling at constant speed. Now, what you do once you have given all these biggest errors letters is you can go through and you can assign them a score or a grade. And maybe you decide that a grade that the perfect one gets an A, or maybe you decide they get an A plus, whatever you decide. And then from there, you can decide the scores for all of the different types of errors all the way down. So a B for maybe the R response and a C for the 2.0. I'm sorry, a C for the third response, the V. And so when the students get their papers back, what they see at the top of their paper is not a grade. It's not a bunch of red marks on their paper. What they see is this code. So they see a Q, they see an R, they see a V, they see an X, they see a W, they see whatever. And then what they do is they go ahead and they look up online and they find this rubric where they have their score, their grade, and then they have feedback that's specific to them. So specific to that particular kind of error. And this is really nice because we make a point of saying what they've done correct and then how they can improve, what they need to be thinking about the next time they see a problem like this. And there are all sorts of other affordances to grading like this as well. So for example, if you are somebody who is lucky enough to have TAs that do the grading for you, and your TA hands you this rubric and you say, there's no way a V is worth a 2.0, this should be a 2.5, or maybe it should be a 1, you can actually just change that score. And then all the students who have a V, all of a sudden all of their grades change. And so that's a really nice thing because you can just change the grades. Or a student can come to you and argue and say, I don't think that this category is really worth this many points. I should get more points, and here's why. And they brought up something you hadn't thought about. Then you can go ahead and change their grades for all the students instead of just saying, well, they were all graded like this. So that's really nice. Another thing that this method allows you to do is you can look at all the common errors. So not just like the students did really badly at this particular problem, but like what specific error are they making? And you can look for themes across different problems, potentially. So that's pretty nice. I'm not going to read through all of these comments, but in general, students are pretty positive about grading by response category. I'm not going to lie, they're overwhelmed at first. They're like, why is there a Q on the top of my paper? I have no idea what that means. But soon enough, they get used to it and they like it because it gives them a lot more feedback on their work. They don't get red marks all over their page. And something that they really like is they like not having to hide their paper after they take their physics test, because like they don't want other people to see their grade. And so this way they don't have to show their grade. We also have some a little bit of data that shows that the students who are using the grading by response category method value reasoning and feel they're rewarded more for their reasoning skills. So we do have some data on that. And again, there's a physics teacher article that goes into more detail about how to use this method. And then also there's some other citations that are useful to describe this method as well.
So every week, what will be perfect will differ, so it will not be Q all the time?
That's a really good question. So Q we always save for being perfect, because we say, okay, well, if they got the perfect answer and we don't have any other feedback for them, then they can just know that they did perfect. But all the others change. So like a W could be an A one week and an F the next week. So they have to look it up. Okay. So another thing, so that's actually, are there any questions on this method? So I have a little bit of time. I'm going, yes, go ahead.
Would you have multiple response categories with the same grade?
Yes.
Right.
Yeah, absolutely. Absolutely. That's another affordance of this, is that you can just have as many categories as you have errors. You want to keep it to like less than 10, and it's actually usually very possible to do that because you don't want to go overboard with that. Yeah, Ed.
Can you say a little more about why you focus on only one single instead of like tagging with multiple?
Yes. Okay, so if you imagine that a student makes two errors. One error, they forget a minus sign, and another error is that they don't conserve energy. Which do you want them to focus on for next time? Conserving energy, right? So we don't care. You miss a minus sign, whatever. But you don't conserve energy, that's what we want you to focus on for next time. And that's going to have a harsher penalty than missing a minus sign anyway. Okay? All right. The other thing that Wendell talked about quite a bit, and this is actually something I was super skeptical about for a long time. David and I had conversations back and forth on this. This performance feedback and evaluation. He really believed that grade scale was really important, and me, being the typical physicist that I am, thought it's just a number, it's just a grade, it's just you pick a scale and you grade everybody the same on it. It doesn't matter. And so I'm going to talk a little bit about the two most common types of grade scales that are used in college. There are lots of different types of grade scales, but I'm just going to talk about two. So first of all, if you go to the College Board website, they show you how to translate your grade, a letter grade, a percent scale, and a 4.0 scale, how to translate back and forth between the two, between them. And what you'll notice is, if you're just looking at this, the scales look pretty similar. There's about the same difference or space between the B's and the C's and the D's for each of the different scales. But what you'll notice is what's very different is the F's. So if you think about the two scales, the percent scale has a huge proportion of the grade scale devoted to failing, whereas the 4.0 scale has the same portion of the scale devoted to failing as it does the other grades. Okay, so what we have here is we have a grade scale that is dominated. I mean, 65%, right? That's 65, more than half of the scale. It's dominated by F's. And so the questions that Wendell had, and the questions that I eventually came around to were, do we really need 60 different degrees of F? And can we even distinguish between 60 different degrees of F? It's an F. It's an F. It's a fail, right? Why do we need a 30% versus a 40%? Like, it's a fail. Okay, so these were things that he felt just by thinking of it. But if you even look at it more mathematically, there's a huge difference mathematically as well. So let's just take an oversimplified case here where we have two students. We have student 1, student 2. They're in the same course, but they're in two different sections of the same course. And student 1, they both get a B on the first assignment. They both get an A on the second assignment. And for whatever reason, they both miss the third assignment. So they both get a 0. They both get an F on this third assignment. For student 1, they have 57.3%. For student 2, they have 2.13. And we can all know what's going to happen next. Student 1 earns an F, and student 2 earns a C. Okay? Now, I can imagine lots of arguments for why an F would be I don't want to say a good grade, but would be an accurate or acceptable grade for a student who missed 1/3 of the class. Okay? But Wendell believed that a grade should be indicate some level of understanding. Okay? And this 0 isn't really a 0, it's missing data. Okay? We don't have data on how well that student could have completed assignment 3. They just didn't complete it, so we don't have information on it. So which of these scores better represents what we know about what the student knows? And I would argue, and Wendell would argue, that this 4.0 scale is a better guess at how much the student is capable of capable is the wrong word, how much the student understands this work. And this isn't a new idea. There are other people who have been thinking about this. I have some citations here. You can look them up. But basically, this was really, really important to him. And as I said, I was very skeptical for a long time about this. And I actually sort of went towards this scale because I thought you should have a harsh penalty if you didn't show up and you didn't do the work. Because that would serve as a deterrent. And you would have fewer students having missing data. But then David, he decided we should actually look at this, okay? And one of the things that we did just recently is because we have the grading by category method in our that we used it, we actually have the ability to go back, 10, 20 years ago and look and see how many students skipped problems and left them blank, or how many students missed a quiz, just didn't show up. And you'll notice that overall, so for the fraction of questions left blank, it's actually pretty low. It's only about 3% of questions are left blank by any students in this class. But there are small but significant differences between different student groups. So you see that the females are more likely to leave blanks on exams than males. And you'll also begin to see that these are more drastic differences when you look across different student groups. So you see that there's an equity issue here, that different students are leaving, different populations of students are more likely to leave blanks on tests than others. And that is going to, if you're using the percent scale, that is really going to harm those students. And what I think is also really interesting is the fraction, if you look at the fraction of exam questions left blank, and you also compare this to the fraction of quizzes missed, so blanks versus missed, you see actually different trends. So women are much less likely to miss a quiz, but they are more likely to leave a question blank. So you see that there's different reasons that students are getting these zeros. So they have different meanings. And again, you see that first-generation college students are just as likely to miss a quiz than from all the other students, but they are much more likely to leave a question blank. So there are a lot of equity there are a lot of equity questions to consider when you're thinking about your grade scale, because it privileges certain populations of students. And if you're interested in this, you can come see our perk poster tonight. I'm happy to talk more about it. I've even got some more plots for you. Yeah.
What is URM and WH?
Oh, sorry, I didn't define that. So URM is underrepresented minority students, and WH is white students. Okay. The last thing I'm going to talk about today is the quantitative impact of Wendell's class course. And I couldn't even begin to talk about the qualitative, and this is just some small portion of the quantitative that I'm going to talk about. So here's a plot at UC Davis. We've got the year along the bottom. I know you guys in the back probably can't see this very well. We've got 1990 all the way up to 2004. And the red dots here represent the fraction of students with a grade lower than, essentially a failing grade. And we have the traditional course, which is the CLASP course replaced, is in red, and the CLASP is the black dots, and the closed dots are for all students, and then we've also highlighted the underrepresented minority students as well with these open dots. And what you can see is immediately after the course was implemented, the fail rates dropped significantly for the course. So it has a pretty strong influencer on student success in this introductory course. And we have a PERC paper that actually shows that this potentially influenced their retention in the major. Yeah, Eric?
How many people roughly?
Oh, yeah, that's a good question. So there's about 1,500 students per year, per column. Okay? That's helpful. So you might look at this and think, oh, well, CLASP is just an easier course. But that's not the case, because with grade inflation, what you'd expect to see a lot more A's and a lot fewer F's. But instead what we see is fewer A's and fewer F's. So what you do, if you look at the traditional course, which is in red, and the CLASP course, which is in black, I want to call your attention to this column over here, which represents the A's, on the 4.0 scale. You have a lot fewer A's in CLASP than you do in the traditional course. But you also, comparatively, have a lot fewer failing grades as well. So it's not just easier. This isn't grade inflation that we're seeing.
Aren't you going to brag on the reduced difference between the underrepresented groups and the rest of the class?
Yes, I wasn't going to get into that, because we could talk all day about that and whether or not it's proportional and all that kinds of thing. But yes, you do see a smaller gap between the underrepresented minority students and the rest of the students. Okay, so finally, I've been doing some work at San Jose State, and to implement CLASP there, it's been a challenge, and I think we're doing pretty well. This is from our dashboard. All the CSUs have this dashboard thing where you can look up the fail rates of any single course in the system, and you can see that in 2011, the traditional course had a fail rate of 17%, and it had a course GPA gap of about a third of a GPA point. And now in 2016, we have all the way shifted our fail rate down to 4%, and our gap between our underrepresented minority students and the rest of the students is very, very small. It's much smaller. So we're doing it. So my summary statements for this talk, when I'm thinking about Wendell here, is that if you must assess, and I add that parenthetical phrase there because I took a grad course with Wendell, and I don't think we had a single assessment in that course. We just showed up and talked about things, and that was wonderful. Assessment should be an integrated part of any course, and it should be student-centered, and it should be part of the learning experience, not a consequence of it. And also, no argument can be won with, we've always done it this way, right? I mean, we can always change. We can always make things better. And he was doing that consistently. Even after he retired, he would meet with me. I'd go to his house in Pacifica, and we would work on curriculum together. And so just my personal thoughts on Wendell is Wendell loved learning. And he shared that love of learning with everybody he met and everybody he worked with. And it was just really impossible not to get swept up in the passion and excitement that he had for figuring things out. And while I really only briefly passed over it today, inequities in science really, really bothered him. And he really wanted to work towards an end where everybody could participate, contribute, and be successful in science. And to those who wish to honor him, I suggest that you go out and look for those inequities and make sense of them. And I think that he would really like that. I will miss Wendell dearly, and I know many of us in this room will as well. Thank you. Any questions? Yeah.
So, to what extent for the grading policy or practice that you outlined, to what extent do you see that as being transferable across the curriculum?
When you say across the curriculum, do you mean?
Within physics, but you can do this way too.
I think it's entirely transferable. I actually have completely switched over to grading this way. I can't imagine grading any other way. And I think Chuck made a comment that it's an investment up front, but once you learn to do it, and even TAs tell me this, it's actually more time efficient to do it this way, and it makes that grading process a lot more meaningful, so you don't feel like you're just wasting time writing scores down on the page. You feel like it actually has some use. And also, we've even streamlined the process even more at San Jose State. I had some slick folks who know a lot of spreadsheet magic that have actually made this process really easy. Yeah, Ed.
You know, I've worked with Chuck and you, and I guess I don't know if that makes me like a nephew or something, like academically, but I would just like to echo the appreciation for his work and really thank you all for sharing your stories and the work that you have done with him and subsequently. It's really impactful. So
I totally echo what.
maybe we can all just like honor that moment and take a lead or something.
Let's say thank you.